After that, transform data and visualize and model and communicate. So why we maybe I should spend 1 or 2 minutes to explain why this is important. Okay, communicating results to stakeholder is important because you want to make sure your analysis and your results can be communicated properly to stakeholder. We want the stakeholder to understand what you have done. We want them to understand the interpretation, and we want them to appreciate what we are trying to convey, and hopefully with that, stakeholders can do something to the practice based on the analysis that we have done. Right. So that's basically what we want to achieve from communicating the results to the stakeholder. And this is not a one step kind of thing. It starts from importing data. Data should be imported properly, and then once you have the data must be put in a tidy form. What do we mean by a tidy form? Most of the time, it means that the data set has columns and rows, right? And each column represent one variable, and each row represents one observation. An example of observation is an individual or a customer or a client. Okay, each row represent that. Okay, so a tidy data means you have rows representing the observations and columns representing the variables. And the next step will be the data transformation. We learn how to do this, how to wrangle data, how to create new variable, how to categorize numerical variable to categorical variables, how to group categorical variable from, let's say, 5 groups to 3 groups, and some other data transformation or data wrangling. And then we need to visualize. We need to visualize our data. Don't go straight to analysis without visualizing your data. You miss very important step there if you do that. So you have to visualize data, and we learn this in data visualization. In fact, we did this very early on, and data visualization might not answer questions. Okay, it does not answer question whether this will result in this or that will result in this, or whether A affect B or B affect C or whatnot. It does not do that. But what it tells you is what kind of data that you have in hand, and is there any strange pattern in your data? Are there outliers in data? How about the distributions of your data? And what kind of questions that you can ask by looking at your data, or by looking at the graphs or the plots? And what can you ask? What kind of questions that you ask? All right, so that are the things that you would like to get from data visualization. And from that, you go to model. We learned this the last 3 weeks. We learned about developing models, and and it is usually you won't get one model, one best model. It's kind of difficult to get that. Sometimes it is not realistic because you don't know what do you mean by a best model, by the best model, right? So you might offer a few models, model A, model B, or model C, and but how do you assess? How do you assess um, each of the model? Um, the model can be assessed based on a few principles. One is what we call as model specification. Okay, model specification. It means that does the model specify adequate informations? For example, does the model have enough predictors? You know, enough predictors. Have the model captured adequate predictors? Second, is the model plausible? Is the model plausible? All right, does it make sense or not? Okay, that's number two. Number three, is it statistically fit? Right? Is it fit or not statistically? Okay, in statistics term, is it a fit model? Okay, is it a fit? FIT, is it a fit model, a good model? Okay, and that would be the three of the things that you would look for. Okay, again, number one, does it make sense? Number two, is it fit? Number three, does it contain all the important predictors? And number four, yes, you can add one more. Which one is the simplest model? Okay, if you got three model, which one is the simplest model? Okay, you don't want complicated model. You want a simple model. Okay, all right. And then once you get this, and this forms a loop. Okay, because it does not end here. From a model, you might want to transform and visualize and model again, transform again, until you are satisfied, and then you know present your results to the or communicate result to the stakeholder. Okay, this will be the outcome of the previous stages. This is another aspect that I think important for data analytics. One is the life cycle of data analytics. Okay, life cycle. Because I think you have got to understand. You have to understand this. Okay, you have to understand this. And an example of life cycle of a business analysis project is this one. All right. So you may start with a business problem. Okay, we may start with a business problem, and then you have the data relevant to the problem. Okay, or you start with data, but you don't have the necessary a model yet, right? So, so you have to uncover the patterns that you see in your data to come up with some hypothesis. Okay, this is this can be said or can be called as hypothesis generation, and this one can be called as hypothesis testing. Okay, this is hypothesis generation, and this is hypothesis testing. And after that, you study the data, clean up the data, and for miss data element, some errors. This happen a lot in data. Okay, to look for the outliers. Look for the outliers. The simplest definition for outliers are data points that stay far away from the rest of the data. Okay, even there are some formal tests to do this, but we did not go there, and in fact it might be too complicated for some of us. So I've decided that we will not go to that level. But if you have outliers, what can you do? One option is by removing the outliers to reduce the adverse effects of outliers to the analysis. All right, so you can remove, but is it necessary or is it required at all time to remove the outliers? The answer is no. You don't have to do this all the time, because sometimes the outliers can be just outliers. Okay, they are only outliers, but they are actually real data. Okay, but if outliers happen due to wrong data entry or some errors during data entry, there you can remove the outliers. But sometimes the outliers are the correct values, then you might want to keep the outliers. Okay, and hopefully these outliers will not be influential to your model. Okay, so there are two terms I used just now. One is outliers, and the other one is influential. Okay, influential. Sometimes outliers do not influence influence your model, and sometimes outliers influence your model. Okay, for the first one, the outliers that do not influence your model, you are not that worried. And then identify the analysis or data analysis technique, whether it is a supervised or unsupervised analysis. What we did before in linear regression and logistic regression, they are supervised technique. All right, they are supervised technique. And next, the final 2 weeks, we'll talk about predictive analytics. That will be also a supervised technique. After that, we analyze the results. I won't say analyze the result. Right? I think this should be analyze the data, but yeah, all right. I think it is acceptable to say this. Okay, analyze the result. Check whether alternative techniques can be used to get better results. Okay. For example, can we use other techniques? Other techniques. Other techniques. For example, generalized additive model or discriminant analysis or other methods. So that is also possible. Okay. But we have not learned this. Okay, what I taught you previously were linear regression, logistic regression, but there are many other analysis, many other techniques that you can use. But hopefully the principles are the same. Okay, the principles are the same. You can apply the principles that that I've taught you before for different types of statistical analysis. Right, and then validate the results and interpret the results. I think we went through this very briefly in previous lectures. Um, um, we don't have enough time to cover this, so that's the reason why I spent only uh, a fraction of time to talk about results validation. Okay, but you have to understand that validating the results is an important cycle in a life cycle of business analysis. And of course, interpret the result is very, very important. We must interpret correctly the results, and we must choose what to interpret. And publish the results, use the learning out of the results, and keep calibrating the model. Okay, you might develop the model this month, and maybe next 3 months, next 5 months, you have to run again the model. You might need to adjust the model because of some changes. This is the framework of business analytics. Okay, where you have inferential statistics, data visualization, reporting platform, knowledge discovery component, data warehouse. So these are the frameworks. Okay, the analysis part, the spreadsheet part, the data visualization part, the infrastructure part, be it the knowledge discovery, and also the data storage. Okay. This is the characteristic of a successful communications of data to stakeholder. Number one, you have to have frequent conversations. All right, frequent conversations with the stakeholder. Second, communicate just enough requirement, and this is important. If you run statistical analysis or diagnostic analytics or predictive analytics, the software will throw you lots of things, a lot of things. So you have to be able to pick important results and interpret those results and communicate just enough requirements for the audience. Okay. Next, become an active listener. And we have to always listen to what the client or the customers want, or if we are doing consultation work, what our clients need, what do they want to get from the model or from the data. Okay, so become an active listener. Ask stakeholders to tell you more. Sometimes stakeholders think that what you are doing, quote unquote, the analysis is straightforward, right? And sometimes they think that what you are doing is too complicated. Right? So I think you have to reduce the communication gap between you and the stakeholders, and because of that, I think it's good to become an active listener and always ask questions. What do the stakeholders want from you? Okay. Communicate with multiple stakeholder groups. Okay, because stakeholders, if if they have different groups, I think that is that makes sense. You have to know how to communicate effectively with multiple audiences. Okay, so you have to be prepared and understand your audience and identify what kind of audience that you are going to communicate with, right? And what levels of complexity that you can convey during the communication. If you are a team leader, then you have to be able to coach others on how to communicate effectively. All right. So if not, you know, it is not effective. All right. So if you are a team leader, which I'm sure all of you will become one, then you have to be able to train others, train your team members to communicate effectively. Do you have to do follow-up conversations? There is one question you have to ask yourself. If you email a report of an analysis, should you have follow-up conversation to provide clarity? You have to be able to communicate using multiple formats. Maybe in the forms of email, maybe in the forms of dashboard, maybe in the forms of bulletin. I'm not sure, but you have to use multiple strategies and multiple formats to communicate effectively with the stakeholder. And of course, it is common sense to be clear and concise of what you are communicating. This is the data discovery process. Okay, data discovery process. I think it is, even though you might not end up as someone who is doing coding or not the one who is going to analyze data, but understanding this data discovery process is important. Okay, it always start with questions. Always start with questions, and from questions, that is gathering of data, and from gathering of data, there will be structuring of data, and then data exploration, and after that, communicating data. So this data discovery process is almost the same as the workflow for data science, but this, I think, is applicable if you want to generate some kind of hypothesis. Okay, for example, you want to understand what's happening. Okay, you don't have any hypothesis to prove, not yet. Okay, at this stage, you want to create some questions, you want to create some data, and you want to structure some data, and to do that, you explore data that you have now, right? For example, you have a big database, and you explore the database, and from there you might come up with some questions, and from that a large database, you might come up with some data that you think might be useful and some others that are not useful. And from exploring that large database, you might have idea on how to structure your data. All right, so 6 principles of communicating data. 6 principles of communicating data. Of course, you have to know your goal, right? To know your goal, what is or are your goal when you communicate data. Use the right data. Yes, common sense, use the right data. But this also means um, converting the outcome variable to the correct outcome variable. For example, if you have count variable, what kind of example that I can use? If you have a number, the number of ventilators that you are selling every month, for example, right? The number of ventilators. Should you use the absolute number of ventilators sold every month, or should you divide by month or by year, and make it into rate, RATE? Should you present uh, um, number, or should you present ratio? Something like that. The matrix, or the unit of the outcome, right? So I think that what we mean by right data. Select suitable visualizations, and of course that's very important. Visualization is powerful. Okay, is powerful, and if you choose the correct plots, the correct graphs, they can tell you lots of things. Okay, they can tell you lots of things, and they can be very, very interesting to the stakeholders. Just showing data, just showing tables will make the stakeholders bored. Okay, so they will just see numbers. By adding some interesting data visualization, you can make a better presentation. Design for aesthetics, and I think we are fortunate because we learned ggplot packages in Tidyverse packages, and ggplot package in Tidyverse can do lots of wonderful and pretty graphs and plots. I think, and I'm sure that all of you have graphs the skill to run ggplot analysis, to make plots, and what I hope to see is that you explore more the power and flexibility of ggplot to make nice and useful plot. Not just nice plots, but nice and useful and informative visualization. Choose effective medium and channel. When you make a report, for example, you make a report using Microsoft Word, or you may make a report based on R Markdown, and you need into HTML. You need to think how to distribute the report. Okay, how to distribute the report. Should you use email? Should you just use email? Or can you use other medium? Okay, other medium. R, for instance, or RStudio, for instance, has a platform called RStudio Connect. RStudio Connect, which makes the sharing of report and the sharing of dashboard very, very easy. Okay, very, very easy. So um, um, so that kind of medium and channel, you have to be creative with that. All right, and check the results. Okay, verify the results, validate the results, check the model, validate the model. Okay, you don't want to go on stage or send some reports and after that notice that you have made error in the analysis. That's why it is important too that we learn about our markdown, because from our markdown uh, we can be sure of the data reproducibility. Okay, it means that if you send me your code, I can run the analysis like what you have done, and I can regenerate the 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 report. Okay, that's what we want. That is integrity. Okay, that's integrity. You can't do this with point and click software. Okay, you can't do this with point and click software. So that's why it is very, very important to have to uphold this reproducibility principle. The elements of the goal, think of who are you going to talk to, the target audience. Are they the layperson? Are they the technical people? Are they the top management members? And who are they? Okay, who is your target audience? What do you mean by each of the results that you are presenting? Okay, what does this plot mean? What does this graph mean? All right, not just number, not just this is a bar chart or this is a histogram, but beyond that, you have to 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 uh, to let them know what you are trying to uh, to convey, what messages that you want the audience to understand. And also state the not state, but appreciate what would be the desired effect from the presentation of the communication. What you think or what you expect the audience to respond, to change, to intervene based on your communication. Communicating data visualization. Okay, communicating data visualization. Again, you have to tailor it for what type of audience. Make sure that you have set up clear framework so that everybody is on the common ground when interpreting the numbers in the plot. And always tell a story when you communicate data visualization. All right, so think of a story, and I think that would be more interesting to your audience. When it comes to statistics, don't overload your reader with statistics. I know that you have been overloaded by statistics and by coding this past few weeks, uh, uh, but when communicating statistics to the stakeholders, don't put everything, every number. And don't try to present all the numbers to your audience. Okay, choose meaningful data. Again, try to avoid statistical terminology if you can. All right, try to avoid as much as you can statistical terminology or statistical data terms, and as much as possible when you show numbers, interpret the numbers. Okay, interpret the numbers so that people can understand. And let's say in the future, maybe a few of you will be consultants, data analysts, or consulting statisticians. Um, these are some of the characteristics that are important. Number one is the availability of support, because many times when you present your work to the customer or to the clients, they have questions, so they will come back to you. So you must be, available to provide the support, and be responsive of the support. Timeliness is very important too, and completeness of the support, and also be pleasant at all time. Focus on the client and project at hand. Use plain English. If you have equations, don't just throw the questions to your client, but you have to say the equation in words. Okay, and it's good to write equation with the correct mathematical notation. Actively improve your communication, structure your interaction and the outcome, gauge your client's knowledge and communications needs on individual basis. Look at the atmosphere. Um, sometimes you want to communicate results based on sometimes when you communicate result, maybe using presentation, but sometimes you want to communicate result using computer. I mean, you want them to take part with you in a workshop and things like that. Look at the atmosphere, the attitudes, and the directness. Okay, practice respect and mentor others. Yes, p-values. In fact, some of you asked me about p-values, and you have to understand that use p-value to alert us to surprising data results. It's just it's just a number. It's just p-value, right? P-value should not dictate your decision or your life. Okay, so don't depend too much on p-value. Okay, don't base your final decision or final answer using p-values. All right, p-value should be an indication of the results or of an association in your analysis. Okay, but that's it. Okay, it is not something that is very, very important. Okay, not something that you can not something that you base your decision on. All right, because and you should also be careful when you see a p-value that is too small or smaller than you expect. Okay, or when p-value is small, for example, less than 0.05, less than 0.05, you tend to say, oh, this variable is important. Okay, but be very careful. Okay, because um, sometimes it just happen due to chance. Okay, due to chance. Okay, and sometimes this was due to some violations of the data. Might be due to real real relationship, but tiny relationship. Okay, so tiny that we shouldn't really care about it. And this usually happen if you have large sample size. Okay, large sample size. It means, for example, if you use data that contain 10,000 or 20,000 observations, 20,000 data, big that you get from databases. So big data and database contain lots of data, and when you run your analysis, you tend to get significant p-value, but they just significant p-value without any real relationship. Okay, um, if you find a p-value that is significant when you don't expect to find one, then you have to dig deeper to understand why that happened. This is the some phrases that you can use when you describe methods and report your result and discuss the finding. Okay, I won't go into details about this, but I want you to perhaps go to the website that I think I put somewhere in the slide, where you can use some phrases to describe the methods, some phrases to report your results, and what kind of phrases that is suitable for you to discuss the findings. Okay, so this is some of the example how to describe the methods. Okay, and this is some of the examples of reporting results. Okay, the first such questions aim to compare the difference, the purpose of experimentary, simple statistical analysis, blah blah blah, right? And table 1 shows, figure 1 compares, or something like that, right? There is I think I provided the link to the phrases that you can use to write this. Okay, or if I don't, then you can Google Manchester phrase banks. Okay, Manchester phrase banks. This is how you can use some phrases to discuss the findings. Okay, all right. So yes, I think that's all. The presentation for today. Some of the materials of this lecture came from this book, Business Analytics Using R, a practical approach by Dr. Umesh Hodigata and Umisha Nayak. This is a very useful book, and it is available online from Monash University. And these are some of the references from the web pages, right? So yeah, that's the presentation for today. This is I think you can see this now. I will not put it as a slideshow. So this is interpreting and assessing statistical model. Okay, so this is basically just some of the things that will help you to understand better linear and logistic regression. So it is almost done, and maybe I will upload this in 2 or 3 days time. Okay, so just to help you with interpretations of linear regression, and especially for logistic regression. I think linear regression, most of you do not have any problem, but for logistic regression, I think some or a few of you might have some problems to interpret logistic regressions, because there are more than parameters that you can interpret. Right.